Okay, this video is for the groups who have been assigned the independent variable of surface area. So surface area is only relevant for reactants that are in the solid phase. And what I'm showing you here is that we have the calcium carbonate reactant in a variety of sizes. Okay, and they're in these different little yogurt containers. And on the tops, on the caps, you're given a range of the diameter sizes. So most of the pieces that are contained in these containers will have a diameter between, in this one for example, 12 to 15 millimeters in diameter, and then these ones get smaller and smaller and smaller. So we've got these 4 different sized pieces. But what we want to get is an actual estimation of the total surface area, because that's what you're being asked to vary. So what I've tried to do is create an example where I've got 4 amounts of calcium carbonate that are basically equal, at least in terms of their mass. The total amount of calcium carbonate here, or of rock here, is about the same. But you can see that because the pieces get smaller, I get many, many, many more pieces for the same amount of calcium carbonate. Okay, so now the idea is you want to come up with some estimation of what is the surface area of your calcium carbonate. So the machine that we're going to use is called the caliper, and you can see right now I've got this caliper pinched on this rock, and the measurement is right here. It's this first one on the left. If I can get my finger in there, the finger's here, there it is. Okay, this first one right here, where that line lines up, it says it's 1.2 centimeters or 12 millimeters. So that is the diameter of this rock, is 12 millimeters. Now just to show you, you just use your thumb and you roll this thing back and forth until it's pinched on your particular rock, okay? So that's how we get the measurements. Then how are we going to do the calculations? Well, the assumption that you're going to be allowed to make, that we're telling you to make, is that the calcium carbonate pieces are more or less spherical. So they're basically spheres, and that way we can use the equation to calculate the surface area of a sphere, which is the surface area equals 4 pi r squared, r being radius. So what I did before this video is I measured some of the really small rocks, and I measured that big rock. So that big rock, we had a diameter of about, come on, I didn't even put a unit. Sorry. We had a diameter of 12 millimeters, 1.2 centimeters, but it's going to make your life easier, I think, if you just get rid of decimal points and deal with millimeters. So the diameter was 12 millimeters, which means the radius was 6 millimeters. So if I want to calculate the average, I have to do 4 times pi times 6 squared, which is 36. And when I multiply that out, I get that the area is about 452 square millimeters. Notice that the unit has changed from a unit of length up here to a unit of area, which is millimeters squared. Now I only had one rock, that big rock, there was just one of them. So if the area of that rock is 452, then the total surface area is also 452 millimeters squared. Now before the video, I also took some measurements of those really tiny rocks, and I found that on average, their diameter was about 2.2 millimeters. So to get a radius, I split that in half. Now I had to measure a bunch of different ones to get that average. So I didn't just measure one rock. I had to do a sampling to try to get a sense of what the average diameter was, and you should do the same. So if the average diameter is about 2.2 millimeters, the average radius is about 1.1 millimeter. So repeat those calculations. The surface area of a 1.1 millimeter radius sphere is 4 times pi times 1.1 squared. And that gives us a surface area of 15.2 millimeters. But because we have to use a lot of those rocks, that is just the surface area of one piece or one rock. So I roughly counted, there were about 120 of those tiny little rocks. So now to get the total surface area, I need to do 15.2 times 120. And then I get the total surface area, which is 1,824 square millimeters. So when we use the smaller pieces, if we use the same amount, so like the same mass of calcium carbonate, but when I use those smaller pieces, it exposes a lot more surface. And so I should see that reflected in my calculations. that even though the individual surface area is smaller, when you multiply it by the number of rocks, you're going to get a greater total surface area. So that's basically the method that we want you to use to figure out an estimate of the total surface area that you're testing each trial with the different sized pieces of calcium carbonate.